Hello folks, well today we've got an Amstrad 901. I know we've got a President Grant, we don't normally do SSB, but we've got it for trucking and farming company, so we'll be doing the FM AM side of that like we've done before. They're very time consuming and I don't think we've got the time today. We've also got a SWR meter with a built-in deviation meter to look at. But today, I want to look at this Amstrad 901. It's a genuine Japanese one. Obviously it's got a problem there. I'll have a word with our friend Gareth at Leeds and see if we can get him to do a new set of knobs for an Amstrad. Because the RF gain's missing. So, there we go. I don't know what's going to be inside this, apart from a dead mouse. This is likely to work very well. So what's serial number? 35281. It's got the bigger ballast resistor. It does at least have a speaker in it. Don't know where, don't know why the speaker wires are cut off, but they are. So usual thing, we'll check, I'll just check that protection diode's intact. It is, because when this has happened, there's no fuse. Anyone gets that the wrong way round, and it blows the IF chip, the bar graph display driver, and the audio IC. So it becomes an expensive repair. But it's actually worth it because it's the Japanese version and these work so well. So in fact we've got two bits missing there. Maybe insignificant. That might be where the speaker connects. I don't know whether we've got a scrap Amstrad type chassis. We have, yeah. This is the remains of Fidelity 2001. We buy them like this, you know, from radio rallies and this like. So it's not me who causes this damage. Yeah, so the speaker wires go down there. So you know what? We'll have the speaker wires off this scrap chassis because they've still got the tags on them. But I don't need to do that now. And they can go on the floor. Right. We'll connect this to power. Off, center, minimum, maximum, all off. We'll get our speaker mounted on the wall, plugged into public address. In fact, we'll press public address. I'll get this connected to power. I actually find this kind of job exciting. And you know it's going to be good results because of the type of set. It's not like you're spending hours on a set which you know is a poor performer. So we're powered up, we're in public address mode. All I need is our standard Cybernet test mic. I will go and get it. So we know it's a Cybernet one because it says so on it. These are of course a Cybernet 002F set. As I've said a lot of times before, the only thing Amstrad about this is the name on the front. I've no doubt that Sir Alan Sugar put some input into what functions it would have when given a list and what case style it had when given a list. So here's the thing. If it works, if this audio amp works, chances are this hasn't got a ruined audio chip.
Testing 1 2, testing 1 2.
Well, there we go. October 25, Amstrad 901, Japan, none of your Hong Kong fakes, 35281. So we're actually off to a flying start. So we'll take the extension speaker out of public address. We'll put it in extension speaker instead. I don't want to plug my test gear in case there's a malfunction. I don't want to obviously damage the test gear. And that's got a little bit of noise on it. I'll need an applicator for the service hole. And let's switch to CB. Let's come on 17. Right. Are we placing any bets for what kind of output it has? You know, this doesn't look messed with at all. I think we've got a good set here. Hands up those of you who think we've got a really good set which hasn't been messed with. Right. What I don't know is where my normal trimming tool is, which is vital. Alright, we're going to have to pull another one from stock. If we've got another one in stock. No, we haven't. And that's in this box of tat. There's one or two in this box of tat. We've got some fuse holders which Mr. Chippy doesn't know about. Here we have see, once I go to the trouble of getting another one out, the original will turn up. Is that the one we use? We've got different widths. Take longer to find the trimming tool than it will to do the job. So that's 20, that's 20, that's a 25, that's a 25, that's a pointy one. It must be the 20s we're using. That can go on the floor. Is it the 20? No, it's not. No, that's too wide. Yeah. I think we must be using 1.5. Anyway, we'll see how we go on. I don't expect I'll break it, but if I do, it'll be up to me to repair it. Right, we're going to go into transmit. Picture in picture on. Is it going to transmit? Of course it's not. No, it's not going to transmit. Because somebody's blown his up, I expect. No transmit. It's not got the crystal missing. It's not got the phase lock loop chip missing. Let's see whether it receives. Let's put 2779125 on the signal generator. No receive. Okay. Have we got some kind of phase lock loop operation? I don't expect we have for a moment. I mean, that doesn't look like... That's not the right position for that VCO coil, is it? It's right down the bottom. I think we'll get an earth, so we're not fiddling about. I'll connect that to power supply earth. That test point, far side of the capacitor. Let's change channel. We're on channel 20. Channel 1 is 0.96. Channel 40 is 0.96. Going to transmit. Different on transmit. Tell you what we'll do. We'll twiddle the trimmer. I'm on channel 40 still. And there we have transmit. So, the fact we've got no receive is probably a VCO error. Somebody's fiddled with it and got it round the neck, haven't they? So, I will need the right page of the service manual. So I can't remember whether we do these on channel 1 or channel 40. One moment and I will go and print off the relevant page. Okay, so I've printed off the appropriate page and let's have a look what it says. I think it's channel 1 on these. Yes, select channel 1. Good. So they want you to do receive first for 2 volts. And capacitor 9 is this green capacitor next to 23. You can hardly see the 9, which is this green one, and it's the far leg, so far from me. So you've got the channel selector switch here, you've got the nearest leg, the furthest leg is where we're testing it. We've got ground to the power supply ground, because the chassis on these sets isn't ground. We could use a can, but today I've got it on the, could clip onto one of those, but today we've got it on here. So we're going to go into, we're doing receive first, and we want 2 volts, and this is screwed all the way down, so quite clearly we want to come up. and the fact that it's coming up, the voltage, this isn't the right tool. We've got 2 volts, and then on transmit we do exactly the same, and it's the red trimmer CT1 for 2 volts. Here's the fun bit, trying to key to, I mean, if you're doing these a lot, you'd make up dummy mic plugs which linked up the transmit. Now this is interactive to some extent, so it may affect receive. Go back to receive, and look, we've got 2.2 volts, haven't we? Let's go back to transmit. We've got 2 volts, so that's absolutely where it should be. So what we're now going to do is right on here, on the VCO, out of lock, and it was 2 volts plus 2 volts is now what we've got. So no TX, RX, VCO out of alignment. So somebody's messed with it, haven't they? It's not done that on its own. But it doesn't matter, it's here to be repaired. And we do the VCO anyway on this chassis on every single set. So we're now going to go to channel, we can do a checksum, but I'm really not going to bother. I just make sure it transmits on channel 40. It does transmit on channel 40. Let's put the meter so you can see it's transmitting on channel 40. And there we are. That's low power. Let's pop that on to high power. Go to channel 20. Still can't hear anything on receive. Right, transmit. Wow. It's 3.9 watts. Don't often see that. Channel 1, 3.9 watts. Channel 40, 3.85 watts. Back to channel 20, transmit current 1.36 is about where it should be on this chassis, and then on low power it's never 400 milliwatts, but we did see it the other day on that really early one, 27. It's not selecting. It's not actually selecting the right channels, folks. It's only selecting the same channel over and over again. So this is a flawed test. Yeah. Right, it's only selecting channel 40. So we've got an open circuit to the channel selector switch. What it's supposed to do, if it gets a malfunction, it's supposed to go to channel 9. Out of interest, let's see where the channel 9 is producing channel 9. Let's go to the frequency counter. It is. So the phase lock loop chip is capable of doing channels other than channel 40. I don't think I've ever had this happen before. We'll have to do the VCO, won't we, again, when this is, if and when this is sorted. So the way this is, the phase lock loop chip receives its instructions from the channel selector switch, and this lower wafer is the one that actually does the channel changing. This upper wafer is what does the channels on the display. So you've got two isolated wafers. I'm going to go through this for dry joints because experience shows that when you get this kind of malfunction, that's what it's going to be, especially if it's also working correctly on channel 9. So I've got the power off, as you can well imagine. Just only pins this side which affect the channel change. I can see some clearly aren't in any way dry joint. That one is nicely dry joint. And then on the channel selector switch, I mean, they look alright. Just reflow them. The next one after this doesn't look alright. In fact, that's not brilliant, and that's on the channel selector side. So that's on the display side. Right, let's power it back up and see whether we've got any channels back. I think the answer is going to be yes, because I can now see the bar graph on receive. Let's plug our, oh no, stay on that speaker. Put our mic back in. So that was dry joints on the channel selector switch. I say confidently. Yep. So once again, I'm going to have to redo the VCO. We have got transmit on, it's off frequency, but we have got transmit on the full range of channels. So once again, we need to redo the VCO because it wasn't selecting channel 1 when it was supposed to be. But conversely, somebody fiddled with the VCO, hadn't they? Right, do that exercise again. We're on channel 1 and we want, on receive we want 2 volts. That'll do. I'll go and get the phone. Well, according to the fraudulent bank department, Amazon are going to take 600 and something pounds out of my bank account, and if I don't think that's my transaction, press 1 and all that kind of rubbish. Well, considering I've only got about £3 in the bank, 600 and something pound isn't going to go out anyway, is it? No, it's not, Mr. Tango. They must think you're born on a Christmas tree, I don't know. Right, so 1.996 on receive. Now we'll have to do transmit again. It's 2.89, so get that readjusted. Oh, that's going the wrong way. You never know which is the right way, because it can be either. So we've got 2 volts on transmit, we've got 2 volts, 1.99 on receive. So we've reset the VCO, and you know what, I will do that checksum. It's supposed to be about 3.6 or something on channel 40. The manual's not, yeah, it's 3.5, and on transmit 3.3. That's absolutely fine. So that's tracking beautifully. Back to channel 20, and for the first time in a lot of years, this radio is now receiving on channel 20. I wonder when it last did that. So the fact it was doing 3.9 watts on all the channels was actually a load of BS, because we only had checked channel 40. So let's have a look. So low power is 260 milliwatts. Now we're on channel 20, that's where we've got to. 260 milliwatts. We've done channel 40 correctly, and let's look at channel 20 on full power. It's 4 watts. And channel 1 is 4 watts. So we'll still go through the tuning because we need to check it's not had anything silly done. No, it's not had anything silly done. This is really working well. So peak of the centre of the peak, spot on, centre of the peak, spot on, centre of the peak, spot on. Melt the wax in this one. Use the trimming tool. That's correct. And we set the power with this one. Of course, I'm doing all that on channel 40 like a twit. Channel 1. Just go through those again. Always make sure you're on channel 20, so in the centre of the band. And what I'm not going to do is, oh, it's good enough. No, I'm not. It's because we're going to redo it properly. It's not a case as if at first you don't succeed, give up and go home. Let's check these placements. There we go. Right, channel 20 is 4 watts. Channel 40 is 4 watts. Channel 1 is 4 watts. Absolutely central. So we'll recheck low power. Low power is now 295 milliwatts. I'm tempted to put 300 milliwatts. Back to full power. And we're now drawing 1.411. So it's 4 watts, 4 watts, 4 watts. I mean, that was pretty well perfect as it came in. Deviation, for what is worth on this test set, and I'll turn the other test set on ready for an exact figure later. Wow, he's showing 1.5 on this test set. It may be, it may not be. Let's have a look at that later. I'm a bit concerned about the frequency. It's far too low. I've got the frequency counter on. I'm not been showing you much at all. So 2779059 is well off. It's got to be over 100 for me to pass. We're not far off at 100. I mean, it should be 79125, but we're well within. If we can get it over 100, it only becomes noticeably low at 085. It only becomes illegally low at 025. So it is okay, but otherwise we've got to start changing the reference crystal, and we're back to where we're going to get one of those from. Right, so that's transmit. Let's do the meter. So on transmit, may as well go to the main. It's full scale deflection, which isn't very helpful. It's supposed to be all 4 lights and just touching the plus 30. So we've got all 4 lights, can you see that? And then we're just going to adjust it so it's just making the plus 30 flicker. And then at least if you've got an SWR problem, you'll see where it is. and that's one bar showing on low power, so that is pretty well ideal. So now we'll go over to the receiver. So we'll come off that speaker, we'll go to the test equipment speaker, we need to put our earth on that. There we go. And we'll switch on the SINAD meter and the oscilloscope, and let's take some readings before we make any adjustments. I'm going to set the signal generator so it's exactly what we've got. 79104. I don't need to adjust that, that's fine. And we're going to start with, we've got 100 microvolts on the radio. Just check RF gains at full. And it's showing 7. So let's see what we've got to put on to get an S9. And it is not much different, it's 300 microvolts. So it's what you'd call a lazy needle. That goes down as full scale deflection, it's now 4. And this is 300 microvolts. It doesn't have one of those. That's working. That's working. Those are working. We haven't checked all the potentiometers. So let's look at sensitivity. We'll go over to the SINAD meter and let's pop a little bit more volume on. Oh, it's magnificent. Somebody's let a brilliant set go here. Just for dry joints and the wrong twiddle. 0. It's 2.9. .5. 0.78. Let's put squelch to full. That's noisy. It's a bit weak at 22 microvolts. Threshold. Let's go to this attenuator. So we've parked at 0.3, we've set the threshold on the radio. It's coming in straight at 0.3, that does want cleaning. So you couldn't ask for more on that receiver, we're going to still do it. Right, 100 microvolts on, we'll look at the oscilloscope. And the detector is not quite spot on. In view of that, I'll look at the IF next. I want more sensitivity on the S meter so I can see this. Got to go to the SINAD meter, so I'm now looking at the SINAD meter, the oscilloscope and the meter on the front panel at the same time. Tell you what, that was slightly out. Imagine you could probably end up with worse performance because of all this. Worse performance on the test instruments. That was spot on. That was spot on. Now we'll do the front end. We've got about 6 dB there. Let's see if we can get any more out of it. That's perfect. That wasn't. Drop the signal a fraction. Or I might have just gained something there as well. Right, let's see if we can get a new figure. Now it's not actually showing any better because the detector was out. Okay, 0.2. What am I doing? I've filled all this in wrongly, haven't I? It's not. Yeah, no, that's 0. It's 0.29 and 0.25 microvolts. What am I doing? So it's 0.28 microvolts, and for 10, it's 0.23. You know, might have got an extra foot range now, but at least it won't sound garbled. And on 20 dB, it's now 0.6. Right, let's do squelch. I do really want to clean this. Oh, I think we'll do S-meter next. So S-meters, oh, but I fiddled with it, haven't I? I was going to say it's come right, it hasn't, I've fiddled with it. I want it to be on S9, just touching the plus 30. So when I now change to a better signal, we've got plus 30 and it all goes down beautifully. So that's the meter. Now I want to set the squelch. To put the squelch to full. And I want that to squelch out. Perfect. And the meter is still correct. We need to set the meter first, we found on these. So we've now got 100 microvolts for full squelch, so it's a stronger squelch. And then at the other end, it's difficult to set because it's noisy control. Still coming in at 0.3. There we go. So I'm going to have to go and... I've lost the applicator for my service off. Okay, well, that's got an applicator in there. We'll turn the power off, take the mic out, and I'll tell you what, we'll unplug everything. So we'll get that in. I'll do all the controls because they're probably all tarred with the same brush. I don't like to do this willy-nilly because it can chase the lubricant out. But there we go. So this hasn't needed any parts. It's not even needed. This hasn't even needed the ballast resistor. Just contemplating how to get to the tone control. Good. Well, we'll deal with this next. So we've had these power tails available for some years. there are supposed to be a couple of ferrite beads, but they go missing, and this hasn't got any to offer. You know, so it's not going to be the end of the world at all. Because if they were there, we'd put them on. So this is the later type, the square round, the more usual type, not those ones which weren't obtainable until Gareth started making them for us at Leeds. That's positive. That's negative. Just check that these are going to go through. So when Mr. Chippy makes these, are long enough to get the ferrite beads on. It actually says positive, negative on the board. Just making sure I know which way round these go. Now we've got on the air test. I've got a flat tyre on the Nissan Leaf we use. We're going to change one of the tyres anyway. You know what happens when tyres come to the end of their life? You start getting punctures. So it was due to go in on Thursday to have the tyre changed, and then Mr. Chippy went out to do the on the air test for that Uniden 200 and discovered we've got a flat tyre. So what I'll do is I'll take the tyre in tomorrow, because it's been ordered. I'll take the wheel in the other car in the Almira, and we'll do the on the air test. We'll do this, may as well do this first because it's going to be on the bench. We'll do this one in the Almira, and obviously we're going to have to spend money on petrol for that rather than not spending money on electricity from the solar panels which we have. So we'll be doing tons of on the air tests until the Nissan Leaf's back. Just unsolder those a little bit better. I think that's going to involve soldering it up to desolder. Need to order more isopropyl alcohol. That's our negative. I forgot to note which colour came off, but that's our negative. So if that's our negative, that one on the left is our positive, or audio hot, should we say. go. Bit of a possible dry joint in the future there. These don't suffer really, but you know, if they've been in a damp environment, the fact they're 40 years old, some precautionary things. At the end of the day, it was dry joints that was causing the channel 40 only selection, wasn't it? Try and raid some isopropyl alcohol from Mr. Chippy. Right, so we'll put this power connector in if we can. We've got these complete power tails made up on eBay. There we go. And we've got these power leads as well. There we go. Just like it should be. I can't get over what a lovely set this is. I have to get the great big 5-litre one out we use for records. I need to order some more of this as well. So where I've been soldering round there, and other people, that isn't the best soldered joint. I'll come back to that. Good. Now that isn't going to work, of course, until it's dried. I'll just solder up that speaker connection. And how handy that we'd got a scrap set with speaker tails. I remember paying £10 for that scrap set from a radio rally. It was Elveston Castle. And I don't know how long it is since they last had any radio rallies. There was a bloke there who he called Mr. Wife, and he'd have an outside stall. It was just, you know, junk like that, and he had to ask his wife every price. It was always £10. Well, what about 8? £10. It'll be something, you know, worth 50 pence. £10. And sometimes it'll be worth something worth £50. £10. Oh, good. Right. If I was a garage, I'd have compressed air, wouldn't I, to do this. That's nice and tight. Because they come, the sockets can get loose. Right, we'll put the lids on. That's probably where the price label was. It said £10. So we're going to twist these because it's another reason you can get a hom. this is the original £90 version, not your $29.99 cheapo version. And this deserves some new screws, not only any screws, but the RS screws. I think where everybody else's screws are 6p each, RS ones are 18p each. But they have the advantage the screwdriver actually fits them. Put those in tighter later. Bet that came through on the mics. It's the bigger screwdriver. Just to nip them up. There we go. Let's see whether it's ready to be powered up or whether it's still wet with the isopropyl alcohol. We'll get the aerial ready to be plugged in. And the mic. I never did the deviation, did I? Put it all together. Well, we'll take picture in picture off because that's no longer relevant. I've never done the deviation. Right, so plug into the test set behind me. It's because I get waylaid and go and answer the phone and find it's somebody, no doubt in India.
Wow.
Right, we'll just take the lids off because it's 4.5 kilohertz deviation. I bet that sounded good on 3 channels at once. Okay. Mic in. Again. I've got a bag here of stuff that was given us. I'll just have a quick look, see if there's a knob in there. I'm not expecting there is. Nope. Not a problem. I'll see if Gareth can make a new set. Power back on. One Anna, Roger. We're not on the aerial, are we? We're on the test set. One Anna, Roger. I'll just see if the Roger bleep's coming over the RPA system. That would be 31. Yeah. Good. We're doing on the air test in a bit. Hopefully when it's still light. Thanks for watching. The Amstrad CB901 with not a lot wrong with it from 1981.